first step was removing the old Babbitt from the bearings. On the bottom I just used the chisel, but from the top I used a torch to melt it out. Brass shims were used to hold up the drive shaft. These are some little brackets I made out of 1" by 1/8" steel. These hold down the drive shaft as well as keep it centered. I had a little hole in the front of the casting, so I used this piece of copper to create a dam because I wanted that hole to be filled with Babbitt. Instead of your traditional damming compound, I found a high heat sealant that can just go in a caulk gun. This was on McMaster-Carr for about $7 a tube. The induction forge worked quite well for melting the new Babbitt. Here I'm just preheating the casting and the drive shaft, getting ready to pour the Babbitt. This is my first time. Wish me luck. I think it turned out really great. Bottom's nice and clean and smooth, ready to get cleaned up. I'm just using a wood chisel. The Babbitt's pretty soft, so I'm not worried about it harming anything. Then I just hit it with a rasp and a file, broke down the sharp edges. Now with the bearing caps on and some 3/16 inch spacers, I'm sealing it up and getting ready to pour the top caps. Now this time I must have done something wrong. I'm guessing either the Babbitt was a little too cool or I didn't spend enough time preheating those caps. When I popped this off, it wasn't exactly what I was expecting to find. You can see there's a lot of cold shuts in there. It didn't quite fill all of the area. One was a little worse than the other, so I decided to start over. Tell you what, I'm glad I did, because it turned out much better the second time around. I decided to go ahead and put some oil grooves in the top bearing caps. So I needed to remove the old liner, so I'm just shearing off the copper rivets that were holding it on. This is some new clutch liner. Keep in mind that it's conical, so it's not just a straight piece. So I laid it on top of there and marked it out, just to make sure I had the right shape. I marked the holes from the inside with the nail, then with the marker, and then just a little hole punch. Something I'm always reminded of is never to assume anything. So I'm going to be making a new drive shaft for this little giant. This spider has a through bolt that it goes through, and it goes through the axle too. And so I was getting ready to lay this out and realized that the hole was not drilled square. So this hole that goes through is not actually square to the drive shaft. And it turns out neither is the hole that goes through this spider. So maybe the spider was attached to the axle or to the drive shaft when they drilled that hole, and that's why it's all misaligned. But either way, now I have to replicate that in this drive shaft. Moments after I told you not to assume anything, I proceeded to drill the hole. The angle was right, but as it turned out, it wasn't centered in the shaft either, so I had to drill another hole. Again, never assume anything. And getting ready to test fit it. It was pretty close. The slots weren't quite parallel to the shaft either, but with a little finesse, a little bit of sandpaper for the pin, it all worked out. used a rawhide mallet on the drive shaft just to try to get everything to seat well. Make sure that P is nice and tight, then peen over the end of the drive shaft just to ensure that that flywheel doesn't come flying off while the hammer's running. Now this piece of steel wasn't quite perfect. There was a couple of small indentations in it. So I just went around with the fine file just to make sure there wasn't any burrs that were going to cut into my brand new Babbitt bearings. Now this pin that holds on the spider to the shaft, besides the key, there's the key there, but this pin that goes through, I wanted to make sure it'll come out in the future if need be, so I threw a little bit of graphite in there. Hopefully that'll be enough lubrication that I'll be able to retrieve that pin in the future. I'll soon find out that the bronze bushing that I had installed had such tight tolerances that ended up causing another problem later on down the road. But it sure fits on there nice now. I noticed I had a little extra slop in this pitman, so I pulled it apart, just took a little bit of material off the top half. Admittedly, I took a little bit too much, but I was able to throw some shims in, and that allows me to have a little bit more of a adjustable pitman in the future. Admittedly, this process would have been a little bit easier had I removed the motor and the motor mount, but after doing it a couple times, I got pretty good at it. Well, here's the moment of truth. What I was hoping for was a very smooth running machine. But as I'm finding out right at this very moment, the tighter tolerances of the bushing I pressed into the pulley bearing revealed that the pulley itself, the casting itself, was pretty out of balance. So what's happening is it's transferring that wobble into the machine itself. It seems like it's almost as bad as before I started this project. Not exactly what I was hoping to see. As it turns out, the machine shop did about their best they could of putting that bushing right in the middle of the pulley, as the surface that the belt's right on is actually running pretty true. But as I look inside there, I can see there's some wobble in that casting. So I ended up taking it apart again and bringing this pulley back into the machine shop. Had them chuck it up in the lathe and remove some material to help true it up. Luckily for me, that really did the trick. I finally got the smooth running machine I was hoping for. I'd like to give a big thanks to Dave over at Little Giant Power Hammers and Les at Commercial Machine Service here in Kalispell, Montana, for helping me get this machine up and running again for many more years of service. Hopefully this video helps you if you decide you want to try to pour some Babbitt bearings or any of the other things that I did to this machine. Thanks so much for watching.